From the Oregon State University Extension Service, this is PolliNation, a podcast that tells the stories of researchers, land managers, and concerned citizens making bold strides to improve the health of pollinators. I'm your host, Dr. Andony Melathopoulos, Assistant Professor in Pollinator Health in the Department of Horticulture.
First, as a brief preface to this episode, my name is Miranda. I am a student at Oregon State University, and I spend around 20 hours of my week working on projects for the Pollinator Health Lab, where our guest today is Principal Inspector. When I told Andony I was hoping to interview him about his beekeeping as a part of my honeybee biology class, I wasn't really expecting for him to ask me to become a podcaster. To add to the fun, Andony has told me to, quote, break the mold of the podcast, do as little research as possible, and ask whatever I want. I am, as a result, thinking on my feet a fair bit, and yet I'm sure we'll craft an entertaining conversation thanks to the fact that everything I've learned so far about this bee searcher has been incredibly engaging. I suppose I would like to start at the beginning. So, When did you start beekeeping and what drew you to the practice?
I started beekeeping when I was an undergraduate. So I was at Simon Fraser University, and at the time it had one of the most, Dr. Mark Winston ran the honeybee program at Simon Fraser University. He's since retired. And he was the authority on honeybees. The book right behind there, The Biology of the Honeybees, he was the author of. And so I remember being in Vancouver, Canada at the time. I came from an urban family. I never had I'd never worked in agriculture before. I was in a medical genetics lab scoring roundworms, Caenorhabditis elegans, crosses of these roundworms on agar plates. And at the time in Vancouver in the 90s, there was a kind of like a resurgence of a back to the land movement. And I thought roundworms were interesting and complex, but they were seemed disconnected from society as a whole. And two, and I wanted to do something kind of more practical. So there was this beekeeping class. It was the last class that Winston taught. So it was called Biology 427, an upper level course, Biology of the Honeybees. And I took the class, and I remember the very first day of the class, he asked if anybody had seen a honeybee colony, and I raised my hand immediately because I'd never have any inhibitions. And he asked where I'd seen it. I said, on the bike ride up to school. And he said, no, that's a weather station. That's not a honeybee colony. So that was my start.
Oh, so you were a part of his last class that he ever taught?
The last class that Mark taught in biology honeybees, I took, and actually the TA in that class was Dr. Ramesh Sagili's PhD supervisor, Tanya Pankyu, who was at Texas A&M. And so I had no idea what I was getting into, but that was back in the 90s, and I've never looked back.
Amazing.
Yeah.
And Dr. Ramesh, he's running the honeybee lab on this floor, sort of adjacent to what you're doing?
Yeah, it's a really great coincidence that we sort of, have this common background, which all kind of traces back to Dr. Winston.
Wow. So at the end of that course, were you independently beekeeping?
No, I still had no sense of it. So what happened was, they had you could work in labs like you're working in my lab. Well, I did the same thing as an undergraduate, and I remember the beekeeper at the time. So they had a beekeeper. So Mark, was the scientist, and there was a technician. Steve Mitchell was his name, and Steve, I remember going to my first bee yard in the Fraser Valley. I think it was it was adjacent to a hazelnut orchard, and I remember we were going through colonies for the first time, doing something in the spring, and I remember getting stung 5 times in the ankle. And I remember I couldn't walk the next day. Like, it just swelled up. But I was still up for it. But we did a bunch of research projects. I remember one that we did was around suppression of swarming, at that time they were working with pheromones, trying to develop a commercial product that would suppress swarming because it's a big problem. And I remember we would go there first thing in the morning and we would go through the colonies and score them and look for queen cells. A lot of very, going through colonies, lots of colonies, needing the replication. And I do remember the one thing early on that I've almost forgotten about. Early on in beekeeping, you have this weird sense of like when a bee lands on the side of the veil, it looks like something is moving, like a bear, because you're not used to being around all these insects. And I remember that distinct feeling of like, just turning my head. It's like, what's that? It's just, yeah, those early days and sort of the mystery of getting into a colony, being surrounded in a bee yard with thousands of bees disrupting colonies. I take that for granted now, but I remember at the time how novel and strange and weird and wonderful it was.
So you have published a lot about bee management, how to sort of combat diseases and pests and things like that.
Mm-hmm.
Was it your experience at this point beekeeping that drew you to that type of research?
No, you know what it was? So the great thing about being in the Winston lab, Mark was a great supervisor, really great. And he would make sure the undergrads, and then I became a graduate student there, went out and did the industry talks. So he didn't do those. He would send us out. So I'd have to go to the Surrey Beekeeping Club I was actually the president of one of the bee clubs as a graduate student the one in downtown Vancouver. And you'd have to sort of encounter people, real people. The thing that I missed being in a medical genetics lab, I had to really talk with beekeepers and learn their issues and problems. And a real pivotal moment for me was I got to go to, as a master's student, to two provincial beekeeping meetings, three in a row. I went to the BC HPA, the BC Honey Producers, the Alberta meeting, the Saskatchewan meeting, and the Manitoba meeting. And the person who accompanied me was a person who's now retired and recently passed, a USDA research lead, Bill Wilson. And Bill was this guy who would go into the room and he would know everybody's name. This is Canada. He's a USDA research leader, but he had this little notebook and he would memorize everybody's name. He'd know everything about their family. And so the beekeepers, I learned there that if you really want to have a connection in agriculture, you have to actually be invested with people. And he was invested. And I also remember I would go to these scientific meetings and people would have these error bars and prediction in these models. And Bill would just put a number up there, 300% increase in honey yield or something. I realized in science communication, sometimes you have to really put yourself in the shoes of the people that you work with to be able to, have any kind of traction. And so when I started to do research, I really always kept that in mind, is that research, trying to think what were the key problems that people face that they had articulated to me, but also thinking that sometimes those solutions have to come in the form of like how beekeeping operation is structured. You can't come up with like a swarm suppressing tool that involves some kind of gizmo. It has to work in the actual operation of a commercial beekeeping operation that often involves 10 or 12 staff, and they're going through colonies. They've got a division of labor. It's very intricate. And, it has to work in that system or nobody will take you seriously. So that was always something that left a deep mark with me.
Yeah, I think those are incredible skills to learn early on in your career. And it seems like you're still teaching those to me and your other undergraduate students.
I hope so.
I can't count how many times you told me to turn data into a picture or make a font bigger.
Oh, good.
So you've been doing a good job.
Well, that's Mark. That was Mark Winston. He also really emphasized that. He became a science communicator at the end of his career and had no patience for anything that was convoluted. He used complicated language. I remember getting I wrote, as an undergraduate, just like you, I did my first paper. It was on using queen mandibular pheromone and trying to understand if it would suppress, after a queen cell was initiated, whether you could suppress it again. And I remember the first manuscript he gave back to me was just full of red. And the thing that he was most kind of keyed into is any kind of like language that was convoluted. He pounded into me, just, it has to be written assertively, straightforwardly. And yeah, that was great. Well, thanks. That's a big honor to be told that.
You're definitely carrying on the legacy. All right, so in preparation for this interview, I looked through some of your publications, and I didn't peruse them super carefully, but I was just wondering if you've noticed anything you've researched implemented into beekeeping, or have you implemented any of it yourself?
Oh man, I don't think anything I've ever done has really been picked up by anybody. No, it's a good lesson, because I think most people think that science is at some kind of like superiority to practice on the ground. And I would say most of the things that I thought would stick have not, like by and large. And so, I remember I knew varroa mites were always the key problem for beekeeping, and I did some work with, well, some of that might have stuck. You don't know, I guess as a researcher, you don't really know how things stick. Like, I did a lot of work with a natural product, thymol, to try and see how to get it implemented in the early days when it was just coming onto the market, trying to figure out, the different products and the release rates, how that affected efficacy. Because with a lot of natural products for varroa control, there's a huge amount of variability in control, which is, very difficult to manage. And so some of that work, I would say, had some impacts. We did a whole lot of work on American foul brood when I was working with Dr. Steve Purnell at the Beaver Lodge Research Farm. And I think, we, along with our colleagues at USDA, were able to establish some of the new antibiotics had quite long persistence in honey, and I think that information actually helped Canadian beekeepers who have to export most of their honey for export understand how to use this product and really be careful with using these treatments outside the fall, because it would end up in honey. So yeah, there are pieces there that have had impact, but sometimes maybe as a researcher, it's hard to know how things have an impact. But yeah, I don't know if there's any slam dunk. We're in this, just a couple doors down from us is Sean Mellenbacher, a world famous hazelnut breeder who saved the hazelnut industry by, coming up with a breed of, figuring out the genetics of a blight. And I haven't had any of those. But sometimes those are hard to come by. You try as hard as you might, but it is difficult, I think. I've had difficulty sometimes.
I think that even if a paper just serves to be a citation for someone else, everything is a contribution.
Oh, I think so, for sure. Everything, you never know. That's the thing I do think is, like, you never know who read something and then they did something with it, and you don't know these connections. That's all invisible to you as a researcher. And I think as a researcher, you tend to be a good researcher. I think tends to be hard on themselves, because they really do feel the pressure of offering service. And if you're so cocky that you're just like so full of in your head, I think that would be a really bad habit.
So you mentioned that some of your early beekeeping experience was as a part of a lab, taking care of bees as a part of experiments. I have a very similar experience through your bees. Mm-hmm. Are these your bees? Like, did you buy them? Are you taking care of them personally and submitting them for research projects, or do they belong to the university?
Oh, they belong to the university. So they were Simon Fraser's. But the thing is I imagine I've seen it with you guys as well, students in the lab, in the pollinator health lab. And sometimes it kind of overflows into your personal life. And I do remember once getting a bee colony, and I remember I bought it, but I didn't have a car, so I took it on public transportation. And some bees did actually, it was a cardboard nuke box, so some bees did escape on the bus, and I had to discreetly go over and squish them. I don't know what I was thinking, but it was actually for a friend, Ryan Dolmage, who actually has passed since. And what Ryan did, he wanted a headboard in his rented apartment, that was a transparent beehive. And so we punched a wall in his rented apartment in Vancouver, and he got the headboard, and Ryan really loved it hot. Like, he had all these plants he loved plant, and his room was really hot, so it was like a perfect environment but he couldn't sleep. So we had to take the colony out. So yeah, no, I have my own personal colonies. And the other example of this was when I worked at I worked at the Beaver Lodge Research Farm. It was the most farthest north agricultural area in North America. It's home to Canada's honeybee lab, and I worked there for about a decade. And there I got to see some of the most innovative beekeepers on the planet. The things that people knew how to do there were remarkable. I just still am drawing on that experience when I talk to beekeepers here. And I started keeping my own semi-commercial operation there where I would produce nukes, which small colonies. And so I would do that after work, because you get all these ideas, you're at work, and when you're in a project, you're in a project, you're kind of constrained. You got to sort of serve, you're given some grant money and you have to do something in a specific way, and you get, but you really want to apply what you learn. So I have periodically had my own bee colonies where I've mucked about and tried my hand at it.
That's awesome. I didn't know that.
There are many secrets.
Yeah, I feel like every question you answered could go in a million different directions from there. I do have a question about that, though.
Mm-hmm.
Could you describe a little bit more how to create a nuke from a larger colony and sort of how you went about selling those?
Yeah, that's a great question. So I had learned from these northern Alberta beekeepers. It's very far north, but they were rearing people think about in Canada that, the old style beekeeping, actually before the 1980s, they would kill their colonies every year.
Wow.
They would kill their colonies and they would get new packages from the U.S. and they would restock. That border was closed in the 1980s because of tracheal mite first and then varroa mites. And so these beekeepers learned how to, in large part because there was a little really efficient college program at Fairview College. It taught all these beekeepers how to rear queens, and they started to rear lots and lots of queens. And the way that they made nukes was connected to this. So because they couldn't get packages, you'd go through the winter and you'd have 20% loss. Very expensive to get packages. At the time, you could only get them from New Zealand. They'd have to be flown from New Zealand on an airplane. It's really expensive. So what they did was, in June, when the colonies started to get strong, they would put on their first honey super. So they've got the brood nest when you come out of winter. You've seen this already. You have one or two brood boxes. And what they would do when the colony got really strong at that point in June, and they're about to put the honey super on, they would take 2 to 3 frames of sealed brood, and they'd shake all the bees off it. So you're just left with the frame of brood. They then replace, you got 3 gaps, 2 to 3 gaps in the brood nest. They put some frames in there from the honey super. They put a queen excluder on, and then they put those frames of brood above the brood nest. Now what that does is that one of the most time-consuming things you can do in beekeeping is try to find the queen. And so you don't have to find the queen because you've shaken all the bees off. They're all below in the brood nest now, and then what happens magically is that the bees then come back up to incubate that brood. They're attracted to the brood. And so then you drive around and you just pick up those frames of brood and take them all to a holding yard, put a queen cell in them, and there they would do 1 frame of brood and bees and a queen cell in June, and that would grow up to be a colony that they could winter. So they'd be making up their losses the following year. And you've seen this here because we actually use these styrofoam nuke boxes, which, listeners, was developed in northern Alberta. So who was the guy up in Fairview? The Cowans. No, not Cowans. That's the extracting company. What the heck is the name? It's going back a few years. They came up with the styrofoam nuke box, and so we do this here. You've been part of this. You were feeding them all through the fall. We make them up in July. We put a frame of brood and bees, a queen cell, and some empty frames, and then they grow, and we feed them syrup. And right now outside, we've got a whole bunch of these boxes that you fed, styrofoam nuke boxes, And they winter really well in styrofoam here in Oregon, and allows me not to have to buy packages every year, reduces my costs. So what I would do in northern Alberta is I had a full-time job. I didn't want to extract honey. So I'd make a bunch of these nukes every year. I'd sell off a whole bunch of colonies except for 2 or 3. And then I would nuke them. I call smash them down. I would just turn them into 40 colonies. And then I'd get them through the winter, and then I'd sell them off again. So I had this. It was equivalent to what many people would call a cow-calf operation. I was not making any meat. What I was doing was I was raising calves and then selling them. And it was really easy. It didn't involve any facilities. I did it all out of the back of a Ford Escort. I've always had vehicle problems in my beekeeping career. Never had a real flatbed truck, as I should have, but so be it. It worked.
What does nuke stand for?
Oh, that's a great question. Yeah. It's a nucleus colony. So it's meant to be a colony that's not in full production. And maybe in some ways this is a holdover from the days when people made, a colony that would make honey, as opposed to a colony that's sort of a colony in waiting. That's, in some ways, that's blurred a bit because, now what's different from the beekeeping that I was used to in Canada is most people here, 75% of their income comes from renting colonies for pollination. And so there the colony size is, dictated by the contracts. But up there, you needed a certain amount of bees in a colony by July 1st if you were going to make a honey crop. And if you didn't have it, it was not viable and it would be considered a nuke.
Right. The far north, you mentioned it was very far north. Is that why this practice sort of began? Because would they usually just destroy their colonies because the winter was so long?
That's it.
Okay.
Exactly. Yeah.
All right.
It was an easy time. In some ways, there was a lot of very small-scale beekeepers at the time because it was very efficient. They would use calcium cyanide. That was the chemical that they would use because it would leave no residue in the comb. It doesn't accumulate in the wax. So they'd kill the colonies every year. And then it gave them a chance to go through their comb, look for problems. The colonies would be killed at the end of August. And so there'd be lots of pollen left in them. So when they got their packages of bees from California, they had beautiful frames to put the bees on. It cut down their costs. And after that, there was quite a wave of consolidation in the industry because it got more expensive to keep bees after that.
So I've learned a lot about beekeeping through my job here, taking care of...
You really have, yeah. We've thrown you over the deep end.
But in Oregon, we've got kind of another complicated situation.
Mm-hmm.
Our winters aren't super long, I don't think, but we do have a drought. So can you talk a little bit about how the drought has been affecting bees and beekeepers and sort of how that's affected jobs like yours and people who are even more dependent on their bees for income?
That's a great question. I think as you well know, and be one of the first people to remind me is that we are running into situations where we have, permanent drought. This year, we still haven't made up our water deficit, and there's some counties in Oregon that are just in perpetual water crisis, and so you can't irrigate your way out of this problem. You have you're going to have bloom that happens early. And you're going to have stretches of time where honeybee colonies don't have anything to eat. And so that ends up the beekeeper having to subsidize with feeding syrup to get them through, keep them healthy. And so I do think there is a big need, and I don't know how to solve this problem. It's one of the things that keeps me up. I don't know how to solve it, and I still am looking for opportunities to solve it, is how to put in drought-tolerant, inexpensive pollinator habitats for not just honeybees, but for the wide variety of bee taxa that we have in the sort of after the blackberries stopped blooming here. That was not a problem I had in Alberta, where the honey flow started and it wouldn't stop until frost. Here we got 80,000 honeybee colonies that really are critically important for agriculture in the state, but also for pollination of California almonds that are going to be running into a crunch.
I did skip a bit of a step, though. We're in Oregon right now, not Canada, and I want to talk a little bit about how you came to the state and sort of what you're a part of here, what you're doing for the Oregon Bee Project.
Yeah, it was a little bit different, because I was a hardcore apiculture researcher, although I had done, I did go and get my PhD later in my life. So at age 40, I went back to get my PhD, and I did work on crop pollination and a native bee system, a really wonderful native bee system in low bush blueberry in Atlantic Canada. I also had a wonderful postdoc with Dr. Shelley Hoover working again on a pollination-related problem. But when I got here, this position was not about apiculture. We already have one of the finest apiculture programs in the world here, so they didn't need an apiculture researcher. But they were having increasing conflicts over pesticide use, wild bees, issues that I wasn't equipped for or didn't have experience with. And so I guess what's held me in good stead here as I've come to Oregon is that the recognition that none of these problems are solvable without broad civil social engagement. You can't solve these problems with a science problem. There's no science question that can get resolved that's going to deal with these. And oftentimes you're going to need to get people working together in some fashion that may not necessarily share the same values. And so I think the Oregon Bee Project came out of the legislature, which also came to the same conclusion after a string of bumblebee poisonings that occurred on linden trees with insecticide use. The Pollinator Health Task Force, struck by the legislature, wanted to see an educational approach, and the Oregon Bee Project has really tried to think about very deliberately about all the stakeholders that are involved and what their educational needs are.
So what are some of the specific things the project does for beekeepers in Oregon?
For beekeepers, a couple things. I would say we work very closely with pesticide applicators, and so and the way that we work with pesticide applicators has been strongly flavored by my interaction with Oregon Department of Agriculture. So Rose Kachadorian at ODA has been a mentor of mine, kind of walking me through pesticide regulation and education, but also Harry Vanderpool, who's a beekeeper, former president of the Oregon State Beekeepers Association. He gives a lot of very impactful talks to pesticide applicators, really focusing in on what, the one thing I always love about how Harry talks to pesticide applicators, he thanks them. He says, you do a great job. If you didn't do this, we'd have vector control problems. We would lose, seed crops. He thanks them. He makes sure that they're respected. And then he tells them, here's some things that can really impact honeybee colonies. He walks them through some of the key pinch points in biology where pesticides can have an impact. But he also kind of gives them a couple very concrete things. Do this, do this, do this, and my life will be so much easier. And so I've really taken that on, and all the pesticide education I do, which is considerable, most of my job is some form of pesticide education, has really focused in on trying to think about, I got you for 40 minutes, 50 minutes, I got to talk to you. What are the three things that I need to communicate to you in a way that's practical, helpful, and allows you to, get your job done at the same time?
Right. I think that's a great approach. Yeah, I think this is a very intersectional project. I feel like we work with a lot of different people from a lot of different sectors, but it all comes around the same sort of problems. And you call it a risk cup. Is that what you call it?
Oh, risk cup. Oh, yeah, right, the risk cup, yeah.
So I think it's fascinating to sort of learn how you practically go about a really complicated issue.
Mm-hmm.
I do want to talk a little bit about your work around pesticides, because I want to learn a bit more about this thing called a pollen trap and sort of how you're using it in research. This summer, I was sweating in clover fields trying to pick all of these pesticide-laden clover leaves and clover flowers as a part of a study you were doing. And you were sort of over the side of the field with some colonies collecting pollen. Can you tell me a little bit about like what pollen tells us about pesticide exposure and how these traps work?
Yeah, the traps were developed originally as a form of income diversification for beekeepers. Well, two things. One was to trap pollen and feed it back to colonies, especially this time of year in the spring when colonies are, you want the colonies to grow quickly, but there is a natural pollen, so if you feed it back in conjunction with other, sources of protein like soybean powder, you can, build the colonies up. But the other thing was income diversification, that beekeepers could make a honey crop and then they'd have some pollen, and people actually eat pollen. They put it, they eat it as a kind of nutraceutical. And so that was the original source. So there's a whole long tradition of very complicated traps, but basically the way they work, unlike the bees that you work on squash bees, which have a scopa where the pollen is, tightly bound on their back legs, and it's kind of like loose. Honeybees and bumblebees are corbiculate pollen carriers, so they kind of add a little bit of moisture and they make a pellet. And so that pellet is often quite a bit wider than the bee if you were to look at them in profile. And so the bees, when they come back through the entrance, there's some kind of gap that a bee can squeeze through, but knocks the pollen off their back legs into a hopper. Now that is, over a few days you can accumulate lots of this. But one thing that's really useful for, and many researchers have used it for this purpose, is that those bees are flying all over the landscape. You don't even know where they're going, and you can tell the plants that they've been foraging on. And Emily Carlson, our PhD student here, does this a lot for her work. You take the pollen, you digest the coat around the pollen in this process known as acidolysis, and you can see the actual pollen structure and you can tell what plant it came from. But also, if that plant has a pesticide residue, then it will also be trapped in the pollen, and you can extract it, and you get this great little snapshot for the time that you were trapping the pollen, the whole kind of composite amount of pesticides that are pollen soluble that are entering the colony. So it gives you this great monitoring capacity for a single colony in a discrete time period. So
I guess if you want to learn more about that, keep an eye out for Emily's episode.
Oh yeah, we got an episode with Emily coming up, and there's some other. We've had some previous episodes on this as well, but it is a great technique, and one that you can't really use with native bees because I think with solitary bees you just can't get enough pollen to do it. Honeybees become a really great indicator species for all the rest of the bees in terms of like pesticide in the landscape.
I've heard some people talk about competition between honeybees and native bees for resources. Do you have any thoughts on that as a beekeeper who also sort of works on conserving native bee populations?
Absolutely. It's an area that we're really interested in developing because beekeepers are concerned about it. Obviously, beekeepers are some of the first people who care about bees. Often we've got, as you know, you were the former label czar for the Oregon Bee Atlas, and so many of our volunteers are beekeepers. So beekeepers are interested in bee biodiversity, and I think it's a complex issue and one that I am still trying to grapple my head around. On the one hand, there is undoubtedly a honeybee colony is unlike any other bee taxa that we have in North America, and the colonies are very large, and so they can a large number of them in one spot can quickly deplete nectar and pollen. But it depends on what you're talking about. There was a great study that was done by Jim Kane, who we've both met, and a really sharp researcher, where he looked at creosote bush, and he looked at the proximity of honeybee colonies to this big mass bloom. The creosote bush is kind of like rabbit brush on the eastern part of the Oregon, where you have a lot of bloom. And he would go and he would look at the anthers and how much pollen was left on them. And he concluded that that bloom is so intense and so strong, there's a lot of pollen that just never gets harvested. So that's one scenario. The other scenario is you have some rare plants with honeybees in the area, and perhaps there's a group of bees that specialize on that plant. What I've noticed, though, is where those rare plants exist in Oregon are typically places where there aren't a lot of honeybee colonies. The siskiyous, the steens, the wallawas. Those aren't really great beekeeping areas, so our bee biodiversity and honeybee colonies may not overlap to a great extent where they are. So that might kind of just be a natural way which we don't have, that competition doesn't manifest itself. But there may be areas, and I think specifically with bumblebees and honeybees, where there may be overlap. I do think, though, one thing, hypothesis that I've been interested in, I just have not been able to pursue. Oftentimes, when people try to create habitat for native bees, they focus on native bee plants that service those native bees. And we know in the atlas there's a whole host of plants that bees visit. But I've often wondered if another strategy, which would be considerably less cost, is planting for honeybees specifically, because honeybees may not venture onto plants that they don't really want to go to if they have an abundant amount of something like a clover. And so I've often thought if maybe that's a dual strategy would be best, where we identify the hot spots in the state where there are intact plant communities and really spend time and money and energy protecting them, at the same time in more agricultural areas creating places for honeybees so that they don't start to wander into those natural areas. They're really kind of sticking into agricultural areas. I don't know, but that's an open question. It's an area for early career scientists like yourself. I think there's some great opportunities there to sort of explore that and kind of come up with some recommendations.
Yeah, that's fascinating. If anyone wants to go answer that question, go for it, I guess. Okay. So we talked a little bit about native bees and honeybee interplay. I want to just touch on the way that the honeybee has sort of become, in a lot of ways, the flagship species for the pollinator crisis, if you will, which I know we've debated a little bit too. But do you think the honeybee is an appropriate representative for pollinator health as a whole?
Well, it's a great question. Yeah, maybe, and that's maybe sort of some of the problem. And I've seen this conversation shift over time. Like, I think it's no longer the case that, honeybees are still broadly construed as, the only bee. I just had, I get many emails from people around the state about concern. And I had one this morning, for example. Somebody wrote in to ask an expert saying, somebody's asked me to put some bee colonies on my property, but I'm really concerned about the native bees. So I'm already seeing a shift, whereas maybe 10 years ago, people only thought honeybees were the only bees. I think now it's sort of, there's a broader sense that there's other bees, and maybe honeybees are, I've heard them described as chickens. So it's like, if you were doing bird conservation, would you save a chicken? Which anybody who's seen a honeybee colony leave the nest and go live in the wild knows it's no chicken. But so, what the question was again?
Do you think they're a good flagship species for representing pollinator health?
I've always struggled with this. I think as extension communicators, we do want a simple message. I just told you with pesticide applicators, I'm trying to boil it down and give them something useful. But there's also, I think, a responsibility to nuance these things. And so, and nuance is complicated. Sometimes I worry when it comes to an expanded set of native bees against honeybees, that there's all sorts of things it's much more complicated picture. And I think even in extension, I think trying to host fora to kind of get at the complications of these things is warranted. Because, when something becomes a flagship organism, it's kind of like, it is an opportunity for education, and it is an opportunity to deepen the conversation. And I guess my philosophy on this, and I don't know if I always follow it, but I would hope I would do this, it would be something along the lines of, rather than use those opportunities as ways to kind of dumb down the conversation, because you can now that you would try to find the opportunities to kind of deepen it. Bee biodiversity is complicated. I am a honeybee person. I'm struggling to keep pace with the variety of life histories and things that go on with these bees. In some ways, I remember somebody saying a metaphor in Greek is a transportation vehicle. It's like a way of getting you from A to B. That's literally metaphor. It's a phoros is to move. And it's like, I guess it's important that to think about those metaphors in terms of where you want to go. And if where you want to go is not to sort of like take an opportunity to kind of add complication and people's limited attention to sort of like taking them down and making them more independent thinkers, critical thinkers, if that's not what it is, I think I would be suspicious. But I think if honeybees were a way of kind of deepening the conversation and allowing people a glimpse into sort of the world of insect biodiversity and giving them surprising them a little bit, then I think it was well served. The extent to which it wasn't, it was just like, one thing that annoyed me, and my PhD was devoted to this, is the whole idea that bees contribute 1 bite in 3. And it's like, well, but 2.5 million bee colonies go pollinate almonds, and they're nowhere on that 2/3 of what we eat. It's like, clearly people don't grow food to feed people, they grow food to, make their farm profitable. Like, farm profitability is a complicated thing, and farm income supports, like this whole kind of range of things that come into play, and somehow we would want to kind of like think about those things more deeply rather than just skim along the surface.
Well, I think that's a fairly good conclusion there. I don't want to take your mic away or anything. Is there anything else you'd like to add?
No, I think that's great. Thank you so much. It's been really great. I always, I have to say, you've taken me all the way back to my beginnings. And so I just, I'm just so pleased to be, I never thought of myself to be in, and I imagine you're going to be in the same boat. I'm hoping in a decade someone's going to interview you and there's like, oh yeah, I was in the Melathopoulos lab and then I went there and then I went there and I don't know how I got here, but it's just like, but it's been great. I was having everybody in the lab, all the students has just been, I guess I never envisioned I'd be here, and it's such a pleasure to work with all of you.
Pleasure to work with you too.
Thank you so much for listening. The show is produced by Quinn Sinan Neal, who's a student here at OSU in the New Media Communications program, and the show wouldn't even be possible without the support of the Oregon Legislature, the Foundation for Food and Agricultural Research, and Western SARE. Show notes with links mentioned on each episode are available on the website, which is at pollinationpodcast.oregonstate.edu. I also love hearing from you, and there's several ways to connect with me. The first one is you can visit the website and leave an episode-specific comment. You can suggest a future guest or topic, or ask a question that could be featured in a future episode. But you can do the same things on Twitter, Instagram, or Facebook by visiting the Oregon Bee Project. Thanks so much for listening, and see you next week.